So let me start with introduce ourselves. I'm Zach, as mentioned, product manager of ScyllaDB. You can see me here at the picture from a few years and a few releases ago. With me today is Mikal, the lead developer for Scylla Manager and responsible for every bug or every good feature that you find in the product. But I guess we'll explain it later. So let's get started. Before jumping into the manager itself, I want to spend some time explaining the motivation. Why do we need the manager? Why what we have in Scylla out of the box is not good enough in some cases. So I will do that by explaining why do you need repair on a NoSQL database in Scylla in particular, and why do you need recurrent repair or recurrent repair automation. And that's where the manager comes in. So what is ScyllaDB? For those of you who are not familiar, ScyllaDB or Scylla is a drop-in replacement for Cassandra, written from scratch in C++ for better performance, higher throughput, lower latency. The database is GA or running on production for about 3 years. About 6 months ago, if I remember correctly, we launched Scylla Enterprise, which is a closed source version of the open source, which is also supported and part of the commercial agreement for Scylla customers. As part of Scylla Enterprise, you also get a Scylla Manager. Scylla Manager 1.0 was released about 3 months ago, and this is what we're going to cover in this session. Scylla Enterprise have other features, but that's not the focus here. So why Scylla Manager? Why do you need Scylla Manager? And to answer that, I will first going to answer why do you need repair, or what is repair on general. So Scylla is eventual consistent database. That means that on some cases, you prefer availability on consistency. So if in case of a network issue, a node restart, a rolling upgrade, and all kind of this kind of issue, you want a database or Scylla to be available and to be alive. And to do that, some of the mutation, as we call it in Scylla, some of the updates might get lost between the nodes. That's fine, that's how it is designed, but over time, nodes will get out of sync with each other, or as we call it, the entropy will increase. And of course, this is usually not what you expect from a database. You expect that if you insert or update a value, and you query it later, you will get the latest value. But if the node's starting to get out of sync, it might not be the case. If you are querying one node with consistency level 1, you get one value. If you do the same query with another node, you get a different value. Usually, it's not what you expected. So inconsistency of data is one problem. A second problem is data resurrection. I will cover that in a minute. So Scylla, by the way, and that's true for Apache Cassandra as well, for those of you who are familiar with that, have 3 anti-entropy tools. The first is repair. We discussed that, and we're going to discuss it in a few more slides. The second one is read repair. Unlike repair, which is an offline process, read repair is a functionality that is executed online in the read path. So usually you set the table for example, 1% of read repair. So 1 out of 100 reads to the database will also, in addition to return back a value, will do a back process of synchronizing this value. So it's very efficient in synchronizing data that you actually read. But if you read all kinds of data on different time, you don't have a pattern, good chance you will miss some of the synchronization. Hinted handoff is another mechanism that we will introduce in Scylla 2.2, which will probably be released in the next week or so. Hinted handoff is another mechanism that is aimed for short-term node unavailability. So if you have like a network crash of 5 minutes, or you restart the server, which might be part of an upgrade or something, other nodes will buffer all the mutations that should have been sent to this node, and once this node is up again, they will replay it. Again, it's another mechanism to solve the asynchronicity problem, but it's not a full solution, and that's why we have repair. So what is a repair? As I mentioned, a repair is an offline process that you, until you have a manager or a similar tool, need to launch manually. You run it on a specific node, and this node will try to synchronize the data with all the other replica on the ring or on the cluster. Basically, it will do like a checksum of segment of data and compare the checksum between the nodes. If there is a difference between the checksum, it will start streaming data from one node to the other in an attempt to synchronize the information. As you can guess, it can be a short process if the data is almost in sync, or especially if you not have a lot of data. If you do have big nodes, which are very common with Scylla, you can easily have like a 10 terabyte of data, and the node was not repaired lately, or even there is a new node or something like that. You have to stream terabyte of data, and of course that takes time. In addition to that, Scylla is, the core database is designed in a way that control the streaming capacity in a way that will not interfere with online requests. So if your database is already very occupied or have heavy reads or heavy writes, the stream will be pretty slow and can take longer. On the other end, if the database is not very busy, streaming can be very fast. So the way to run a repair on a Scylla cluster is using a tool that I'm assuming a lot of you guys know, which is called Node Tool, the CLI tool to control Scylla. You can run Node Tool repair on a node, and it will synchronize this specific node with other nodes. It will not synchronize every node with every other node. It will synchronize this node with other nodes. And that's one of the problems that we want to solve. Another problem that I mentioned earlier, so I already mentioned that the fact that node might have different information as a result of all kinds of issues. A second more tricky problem that some users are not aware of is the resurrection problem. So I want to explain it briefly. So in Scylla and other similar NoSQL database, there is no real delete operation. When you delete a value, you're actually doing an insert of a tombstone. So if you want, you are covering or you bury the value in the grave and put a tombstone in it. And if you query the same data, the tombstone will mark back to the client that there is no value. But on some cases, one of the nodes, like in this example, might not be available. So this tombstone insert will fail for this node. So far, so good. If you're working with a consistency level of quorum, you can still read the data. You will get the right value, that the value is not there actually, and everything is good. So everything is by design, but there is a configuration value in Scylla that the name is GC gray second, which is basically, the name stands for garbage collection grace period. That means that after 10 days by default, the compaction process in the background will remove the tombstone because you don't want to keep this tombstone forever. The compaction will remove the tombstone. And as a result of that, a read operation to the database might fetch the value that was supposed to be deleted 10 days ago or 20 days ago. And so the user experience that you get, that you delete a value, for a week or so, you try to query and the value is not there as expected, but after 10 days, the value resurrect again and come back for the dead. And of course, that's confusing. That's not what you expected. So one way to solve this issue is to run a repair on the entire cluster recurrently. Recurrently, I mean less than 10 days. So the recommendation for Scylla cluster on production is to run a cross-cluster repair every week or so. But to do so, you need to either to run your own scripts or cron job, etc., or using Scylla Manager. And that's what we're going to present in a few minutes. So just to understand better what users are doing on their deployment cluster, we have a pool here that you should pop up on your screen. Okay, it pop up on my screen. And you can answer it at any point. And at the end of the session, at the QA session, we will see the result and maybe try to understand better how people handle this recurrent repair task. So we do have the node to repair, and it's working. It's something that's available in Scylla from day one. So what's the problem with that? Why do we need more than that? So first of all, a node to repair is node by node operation, and what you need here is cross-cluster operation. So you need to synchronize and orchestrate a repair across all the nodes. That's one thing. Second thing, node to repair is one-time or ad hoc operation. And what you really want is to run the repair every week, as I mentioned. Third problem, that a node tool try to synchronize the node in one big bulk or one big segment that can take either a short or a long time, but there is no way to stop this process in the middle. They're actually not a good way to understand how much was repaired. And if it failed and you want to restart, you cannot do that. You have to start the process from scratch, which is not pleasant. As I mentioned, repair can, in some cases, stream terabyte of data. So it's quite costly to start from scratch. There is no failure handling. It's not really a highly available process, the repair itself. Although the database is highly available, the repair operation is not. And it's shard ignorant. What do I mean by shard ignorant? Scylla internal architecture is shard per core. That's one of the keys for our performance. I won't get into it right now, but if you are naively run node to repair, the tool just ignore that fact and just try to repair segment that cross the shard boundary, and it's just take longer. And last thing, that the node tool itself doesn't have a great external integration. So it's hard to script around the node tool. Although Scylla itself have a REST API, it's not easy to use it. And the node tool doesn't export metrics as well. So it's hard, again, it's hard to understand where are you in the repair process. It can take a day, but you don't know if you have a day or an hour or a few seconds for the repair to complete, and that's pretty annoying. Okay, so finally we come to the Scylla Manager, the reason that we are here today. So Scylla Manager is a product that aims to solve all the problems that I mentioned earlier. It's a centralized, highly available server that can manage and control many Scylla clusters. So one manager can actually manage more than one cluster. And when I say manage, it's have more than 1 minute. So on Scylla 1.0 and 1.1, the manager can run recurrent repair with different options, as we will see in a few minutes, and not much more than that. We do plan to extend the manager to do much more than that, and at the end of the session, I will enhance on that on the roadmap. As you might be able to see here, the manager do have its own small Scylla cluster just behind it. I'm not sure you can see it. So to make the manager highly available, the manager do need a persistence database as a backend, and just by chance we're using Scylla as a backend. You can either, if you will install manager, by default it will install its own backend on the same server, but you can also connect to any Scylla cluster as a backend and use that if you want to. And there is a documentation on that, and we'll show all the relevant documentation after the webinar. So Scylla Manager is highly available, centralized controller. The main tool to control or work with Scylla Manager is a CLI tool that's called SC tool. I'm not going to spend time on it because Mikal will. It allows you to automatically set and run recurrent repair on a Scylla cluster. You can also run an ad hoc repair at any second or any day. You can stop a repair, restart a repair, retry a repair, and all of that. And the key for that is the fact that what the Scylla Manager is doing, it is not, unlike the node to repair, we just run a huge bulk, as I mentioned, the manager will split this huge bulk into small pieces and repair one after the other. And if the server fail or you want to stop the repair or anything like that, you can just stop at a certain segment, and when you restart the repair, will start from the same segment. So it's make it much faster and more highly available. The manager itself is optimized for Scylla, so it will split the segment that I just mentioned into a by shard base, which make the entire process, the cross-cluster repair, much faster than if you try naively to run node to repair on each node one after the other, which will work as well, just a little bit slower. The manager itself is completely stateless, and as I mentioned, use the Scylla database itself as a backend or as a data store. The API that the manager exposed is the CS tool that I mentioned earlier. It's also exposed the REST API, and it's also exposed Prometheus format metrics that connect to a Grafana dashboard. For those of you who are familiar with the Scylla monitoring stack based on Grafana and Prometheus, this should look familiar to you, and I have a screen capture of this dashboard later in this session. And by that, I will switch to Mikal.
Okay, thank you, Tzach. In this section, I'm going to show you how Scylla Manager works in practice. Okay, can I have next slide, please? Okay, so Scylla Manager ships into components, the server and the client. So there's no UI currently. We'll probably add that in future versions. So the client is SC tool, that is a CLI tool that consumes the REST API exposed by the client, by the server, sorry. Server manages multiple Scylla clusters and communicates with Scylla nodes using the Scylla nodes REST API. And there is no JMX in the middle, so we consume directly Scylla node as API. By default, Scylla nodes bind API address to localhost, and to overcome this and to avoid the need for changing configuration on the nodes, we establish SSH connection to a node, and then use SSH daemon on a node to tunnel the connections to Scylla node. And this way, Scylla Manager can interact with clusters without integration in the environment. Can I have next slide, please? Scylla Manager, both client and server, are implemented in Go. And Go is a pretty good language for this kind of tooling because it has a pretty good networking library. It's pretty efficient in terms of like development efficiency. It's nice to work with, and the performance is also good. The server itself is stateless, or more or less stateless. All the metadata is stored inside a Scylla database. And while working on this project, we also developed an open source GoSQLX that is Go Cassandra driver extension that provides easy binding and scanning of values, and also SQL query builders and migration tooling for Cassandra. Okay, can I have next slide, please? Okay, so SC tool. SC tool is a tool that you'd probably use unless you're using the REST API directly. So if you're planning integration, that's probably a way to go. Otherwise, you're probably using SC tool. So for human operators, the command line is the preferred way to go. This is a POSIX compliant tool, and we provide a bash completion. So if you ever use some sort of CLI tools, I hope it would be easy to understand for you. The problem domain is split into three categories. So we have a cluster that is intended for cluster registration, repair that is used for seeing what can be repaired, triggering the repair, and seeing its status. And also we have task that that is about managing recurrent tasks. So at this point, it may seem a little bit artificial because we currently only have repair, but in the future we'd have a lot of different tasks. Okay, can I have next slide? Okay, so let's see how it looks in practice. So the very first thing that we need to do is to register a cluster into Manager. So we have an existing cluster. We know IP of some nodes. And upon registration, the Scylla Manager would discover the topology and see what key spaces they are and perform some automatic actions that would schedule the Reaper with default schedule for you. May I have next slide? So what really happens is that when we registered a cluster, we would get something that we call Reaper units. So Reaper units is more or less a key space. So Reaper unit is something that we can Reaper in one job, in one task. And we have possibility to Reaper a key space or its subset. Can I have next slide? The other thing that is created for you is the Repair auto-schedule task. And this is the task that is running periodically with interval of 7 days. And when it runs, it would resynchronize the Repair unit list. So if you added a key space or a key space was deleted, it would be updated. And for each existing Repair unit, it would schedule a Reaper in 2 hours from when it runs. So this task runs automatically every 7 days, but can I have next slide, please? But we can also run it, enforce running it. And when it's being run, you can see that the that the tasks are created to repair all the key spaces. Okay, apart from that, what we can do is that we can schedule repair of a particular repair unit. And we have a possibility to specify when it should run, what should be the interval, and what should be its tolerance for errors. So how often should it repeat? And to see the progress. So if it's running, we have the possibility, we have Reaper progress command that would show you progress of a running Reaper. So the Reaper process operates host by host, and all the shards are Reapered in parallel. This command also provides a detailed flag that would show you progress on each and every shard. So if it's running, we can stop it. You can see in this example, it was stopped at 10%. And then we can actually resume it, and it would continue where it left off. Okay, so that would be it for this very short demo. Saf, please continue.
It took me a second to unmute myself, sorry. So Scylla Manager is available. If you are a Scylla customer, you can just go and download it from Enterprise Download. You have the URL here at the top. If you're not a customer and maybe you want to be a customer, you can download the Scylla Manager for evaluation and just take it for a spin. Scylla Manager 1.1 was actually released earlier today, and it's just by chance that it's on the same day of the webinar. It was actually, we planned to release it earlier, but tested a little bit longer. So if you go to the download site right now, you will already see Scylla Manager. 1.1 compared to 1.0 include a lot of small UX improvement and CLI improvement. The two main new feature in this release, one is a Prometheus integration, which augmented by a Grafana dashboard that we created. So if you download the Scylla monitoring stack and just run the latest release, you will have the Scylla Manager dashboard already available there. Of course, you need to go to the Prometheus configuration and point it to the manager IP so we can start pulling the information. As you can see in this example dashboard, it's present the progress of a running a repair, in this case 34%. Each cluster that you manage have its own dashboard. So you need to choose the cluster on the drop-down menu at the top, and you choose if you're managing many Scylla clusters from the same manager, you pick the cluster and then you see the progress. Or in some cases, of course, there is no repair running, so you wouldn't see that. In addition to that, we added a repair and a fail segment. When you're doing a long task of repair across a big cluster, it's pretty common that some of the segment fails. Why? Maybe the node was down, maybe the network was not up or anything like that. Usually you don't want to start the entire repair from scratch just for these few segments. So what the manager will do for you, once the entire task will be completed, it will try to repair only the failed segment. It will do it, I think, 3 times. And if that failed, just stop trying. And of course, you can run the entire repair again or just wait for next week. All of these parameters are in the configuration, the Scylla Manager YAML, if you want to control the number of retrying the repair or repairing the repair, if you will. So as I mentioned, we have great plans for Scylla Manager. Managing the repair is only the first step in many steps that we're going to take. And this roadmap include our general direction that we're going to take with the manager. We do plan to have at least one more release that focus on repair with some more functionality. And after that, we will start adding functionality for managing the cluster beyond recurrent repair. Things like creating a cluster, adding a node, removing a node, running a cross-cluster configuration change, backup, and all kinds of cluster management will be done by the manager. So that's the roadmap. I'm sure you're aware of it, that this roadmap usually change over time. And I want to take this opportunity and say that if you are a Scylla customer, you plan to be a Scylla customer, and you want to share your input about cluster management in general and Scylla Manager in particular, you are more than welcome to contact me after the webinar. My email should be on your screen right now, and most of our customers, I hope, know it. So if you do take the manager for a spin or just have any general feedback on this presentation or on the manager roadmap, I will be more than happy to talk with you. So please do. And by that, I think we are out of official slides. And before we jump into the QA section, let's see the result of the poll that we did earlier. So the question was, how do you run repair on the production system? We didn't mention what database even, so some of the answer might refer to other databases. So a few people don't know what repair is, maybe not a Scylla users. It's look like 32% are using their own mechanism to do recurrent repair, either with a cron or something like that, but it's the most answered option, but not the majority. So what if you are either running manually or you run your own mechanism to run recurrent repair, I do recommend you to move to the manager. And I hope I convince you in this session that the manager do have advantages on top of just running node to repair. And not only it's easier to manage, but it will simply run the repair faster. So the repair will take shorter, and that's an advantage already. So with that, let's see if people have questions. And okay. So the first question, can I use Scylla Manager as an open source user? So Scylla Manager itself is a closed source product, is like Scylla Enterprise. Technically, it can work with Scylla open source. It's not something that we will support as part of the commercial agreement, but if you want to take it for a spin, you have an open source Scylla, you want to test the manager, it will work with it because it's using standard API. I hope that's answered the question. Second question. Just a second. Okay. I want to organize my cluster. Do I have to run tool as root or any other special user? So by default, when you install the manager, which will ask you to create a specific user on your Scylla nodes, and it will use this user when it contact the nodes, and usually you will do it over SSH. But if for any reason you don't want to use SSH, you already have connectivity between the manager machine and the other machine, you don't have to use this specific user. You can use whatever users that you want. As long what you do need to validate is that the manager have access to the REST API that Scylla expose. By default, when you install a Scylla instance, the REST API will only listen to a local IP, and that's on purpose because for security reasons, you usually don't want to open it publicly. That's why we usually keep it that way and use the SSH connectivity. What is the recommended way, I guess, of running repair? So the default duration with the recurrent repair is once per week, and that's the recommendation. Sometimes we want to run it manually if for example, you have a multiple failure on the cluster or something like that, but it is recommended to run it at least once a week. And as I mentioned, the reason that you want to run repair in a shorter time span than the grace period of the garbage collection. So you don't, and by garbage collection, I mean the resurrection and the removal of tombstones. So if the default of removal of tombstone is 10 days, as it is in the Scylla YAML usually, you want to run repair in something which is less than 10 days. Can I still run okay, just a second. Can I still run node to repair? A good question. Yes, you can. So the node to repair is still there. You can still run it, but the manager will not be aware of the fact that you are running node to repair. So the manager try to only run one repair concurrently on the cluster. You will not run overlapping repair. So, and we take care of that. If you try to schedule to repair at the same time, it will actually run one after the other. It's by design. And if you run node to repair, it will work, but the manager can kick off another repair at the same time, and both of them will run on the same time on the cluster. And it's redundant and it's not really necessary. So if you want to do that, you can. It will work, but the manager will not know about it, basically. So another question regarding the grace period of tombstone. So the default of the tombstone removal is 10 days. That's why it's recommended to run per week, and that's usually the default, and that's a recommendation that we have. If for some reason you change the GC period, you might want to run a repair more often. And that's all the question that I have on the tool here. if you have more question, please publish it. Mikhail, anything to add from your side on any of the questions?
Well, just one comment on the user side. So when you install a Scylla Manager, it would create Scylla Manager user, and the Scylla Manager runs a Scylla Manager user, and you provide system the integration. Other than that, you need to have user created on nodes when that you access. But it's up to you if you already have a user to access those nodes, and I guess they are in most cases. You can read.
Okay, thank you. And the last question, I guess, for today. I want to test read-write on a Scylla cluster, and if I understand the question correctly, run repair at the same time. What is the recommendation about frequently of running these tools? So first of all, it's a smart move to test that because on production you will have a runtime request and you might want to run repair at the same time or maybe during the night or something like that. To test performance of Scylla, you can either use Cassandra Stress or you can use our own tool, which is called a Scylla Bench. It's under the GitHub of the Scylla project. And for the actually running repair, I do recommend to use the manager because the repair there are split into segments. It will be more efficient. But you can also use Node to repair it. It will work, just takes a little bit more time. Okay, I have more questions and a few more minutes to go, so I will try to answer. Just a second, please. Does it identify the node that went down which range to repair? Does it print output of those ranges? I'm not sure it does. Mikhail, can you answer this one?
No, we don't currently support that. So
okay.
No.
It's an interesting request, and I'm taking note of that. Maybe it's something we can consider adding in the future. You will know that the node is done, by the way, if you are using the Scylla monitoring, as you should, you will see that the node is down from the monitoring. And the segment that are repair or not repair are stored in the database, or in Scylla in this case. So we're not exposing it through the SC tool, but the information is there. And last question, Mikhail, is for you, I guess.
Yes. So yes, it's based on GhostSQL. It's like an extension, as I said. So I encourage you to go to GitHub issue and give it a spin. What we added is easier binding of parameters. And what I mean by that, you can bind query parameters from struct, from a map, from both, and you can scan query results directly into a struct or slice of structs. In addition to that, we have a query builder for SQL that's pretty much covers all the data modification spec. And in addition to that, we also have a migration package that you can use to have incremental database schema changes. It does not add shared awareness because it builds on top of GhostSQL, and to actually do that, you need to interact with the driver itself. So this shared awareness would require a driver change. This is something we're looking at, but it's not part of GhostSQLX, and it will not be part of GhostSQLX.
Okay, so that's, I guess, the last question. Thank you, everyone. Thanks for the question. It's a little bit more interesting than talking to ourselves can become boring. So thanks for making it a little bit more interesting. And that's it, I guess. See you on the next webinar.
Okay, thank you. Bye.